Ladies and gentlemen, welcome to our session on industrial crops, advanced topics, and extensions. The 21st century has brought new challenges and opportunities for agriculture. Beyond simply producing food, farming today is called upon to deliver sustainability, nutritional security, and meaningful contributions to the green economy. In this evolving context, industrial, aromatic, and medicinal crops are gaining renewed importance. Once considered secondary or niche, these crops are now recognized as strategic assets in the global shift toward a bio based economy. They are no longer valued solely for their raw yields, but for their multifunctional benefits, their ability to regenerate soils, support biodiversity, provide high value products, and link agriculture to industries as diverse as biotechnology, pharmaceuticals, cosmetics, and renewable energy. This redefinition reflects the profound transformation of global agriculture in recent decades. Climate change, population growth, urbanization, and shifting dietary patterns have placed enormous pressure on traditional farming systems. As a result, crops such as hemp, lavender, echinacea, or even biofuel oriented oilseeds are being reimagined as solutions not only for farmers' livelihoods, but also for society's broader challenges. Throughout this unit, we will explore these themes in detail. We will examine the benefits and challenges of industrial crops, highlight the cross disciplinary connections that make them central to integrated food and industrial systems, and analyze the emerging trends, technological, economic, and policy driven, that are shaping their future. By doing so, we will not only understand the biology and agronomy of these crops, but also their broader role as engines of innovation, sustainability, and resilience. Industrial crops offer a wide range of benefits that extend far beyond the farm gate. For farmers, they represent an opportunity to diversify operations, reduce risks, and improve resilience. By incorporating crops like hemp or switchgrass into rotations, producers can use marginal lands, improve soil health, and create more efficient systems. These crops are particularly valuable because many of them thrive in poor soils or low water conditions, increasing land use efficiency where traditional food crops might fail. Economically, industrial crops open doors to value added opportunities. Take hemp, for instance. It can be processed into textiles, bioplastics, building materials, and even medical compounds. Cotton continues to support the fiber industry, while oilseeds such as sunflower and rapeseed are expanding into biofuels and biopolymers. In this way, industrial crops generate income not only from primary yields, but also from secondary processing and innovation driven markets. They also play a vital role in supporting rural economies. By requiring processing and manufacturing, these crops create jobs in local communities and stimulate entrepreneurship. In recent years, new markets have emerged in green technologies, renewable energy, and sustainable materials. Farmers increasingly benefit from contract farming models, which provide price stability and secure access to these expanding markets. However, the development of industrial crops also comes with challenges. In many regions, market infrastructure remains limited. Farmers may struggle to find buyers, processing facilities, or stable pricing systems. Agronomically, these crops often require new knowledge, specialized seed varieties, adapted equipment, and unfamiliar cultivation practices. On the regulatory side, industrial crops face strict and often complex standards. For example, biofuels must meet sustainability criteria, export crops must pass international quality checks, and fiber production requires compliance with safety and traceability systems. Policy uncertainty, especially regarding subsidies, renewable energy mandates, or shifting environmental regulations, creates additional risks for farmers. Financial barriers are also significant. Transitioning to new crops requires investments in equipment, training, and sometimes certification. but financial support is often limited. Finally, there are still research gaps. Improved varieties, advanced production techniques, and comprehensive sustainability assessments are urgently needed to unlock the full potential of these crops. In summary, industrial crops stand at the crossroads of opportunity and challenge. They offer clear pathways to diversification, sustainability, and innovation, but realizing their potential requires coordinated action between farmers, researchers, policymakers, and industry. Ladies and gentlemen, industrial crops are no longer viewed as separate from food crops or as marginal additions to agricultural systems. Increasingly, they are seen as integrated components of broader food, energy, and industrial networks, contributing simultaneously to food security, innovation, and sustainability. One of the clearest examples of this integration lies in the shared use of infrastructure. Oil processing facilities, grain storage units, and transportation networks now serve both food and industrial purposes. This overlap improves efficiency, reduces waste, and makes it easier for farmers to diversify without needing entirely new supply chains. Industrial crops also play a key role in soil health and crop rotation. By alternating cereals with crops such as camelina, flax, or miscanthus, farmers improve soil structure, restore nutrients, and break pest and disease cycles. In this way, industrial crops support the long term resilience of food production systems. Equally important is their ability to make use of marginal resources. Switchgrass and miscanthus, for instance, thrive on degraded or marginal lands that are unsuitable for conventional crops. Winter camelina can be cultivated as an additional seasonal crop, filling gaps in traditional rotations. Agricultural byproducts such as straw, stover, or manure can be transformed into biofuels or used as natural fertilizers. These synergies increase overall system efficiency while reducing the environmental footprint. Another dimension is the rise of dual purpose crops, which serve both food and industrial markets. Flax is a prime example. Its seeds provide nutritious oil and food ingredients, while its fibers are processed into textiles and biocomposites. Sunflower oil is consumed both in kitchens and in industrial applications, while its protein rich meal supports livestock and human nutrition. Emerging crops such as camelina, hemp, and specialty oil seeds like crumb or pennycress show similar versatility. These cross disciplinary synergies provide farmers with greater flexibility and resilience. By having multiple income streams from the same crop, producers can reduce their risks in volatile markets. At the same time, resource efficiency and shared infrastructure reduce environmental impact. Looking ahead, innovation will depend heavily on interdisciplinary research and collaboration. Advances in plant breeding, biotechnology, and processing technologies will expand the dual use potential of these crops. Meanwhile, sustainable practices such as intercropping, regenerative farming, and habitat creation will strengthen their ecological role. In short, industrial crops are no longer confined to a single function. They are becoming bridges between food systems, energy systems, and industrial economies, a transformation that holds promise for both farmers and society. Dual purpose crops play an increasingly important role in modern agriculture, offering both food and industrial value and giving farmers greater flexibility and profitability. A good example is flax. Its seeds are widely used in food and oil production, while the plant fibers are essential for textiles and biocomposites. Sunflower is another key crop, providing high quality oil for food and industrial uses, along with a protein rich meal that serves as an excellent feed or food ingredient. Newer examples are also gaining attention. Camelina produces oil suitable for nutritional supplements and biofuels and fits perfectly into rotation systems. Hemp stands out as a crop valued both for its strong fibers and its protein rich seeds. Specialty oil seeds such as crumb, pennycress, and lescarella support niche dual markets and contribute to diversification. These crops offer important synergies. They help mitigate risk by providing multiple income streams, improve resource efficiency, and allow the use of shared processing infrastructure, which in turn reduces environmental impact. Advances in breeding, biotechnology, and processing technologies continue to expand their potential. They also bring environmental benefits by reducing inputs and enhancing landscape resilience. Looking ahead, strengthening dual purpose crop systems will require cross disciplinary research, biotechnological innovation to enhance dual use traits, advanced processing technologies, and stronger market development to support integrated production chains. We now turn to the emerging trends and future directions that are redefining the role of industrial crops. This sector stands at a critical moment in agricultural history, driven by global environmental pressures, rapid technological advances, and new policy frameworks. One of the most important concepts is the circular bioeconomy. Unlike traditional linear systems, where agricultural products are harvested and consumed with little consideration for byproducts, the circular model seeks to use every part of the crop. Industrial plants thus function as integrated biorefineries. For example, canola and sunflower produce not only edible oils, but also biofuels, protein rich animal feed, and biomass energy. Hemp similarly provides fibers for textiles, raw material for bioplastics, building materials, and bioactive compounds for health industries. The guiding principles here are resource cascading, where each part of the crop serves a purpose, sectoral symbiosis, where industries share resources and byproducts, and biological technological integration, where new methods connect farming with processing and innovation. The result is greater profitability for farmers and reduced waste and emissions for society. Technological progress is central to this transformation. Biotechnology innovations such as CRISPR and marker assisted selection are being used to develop new crop traits, higher yields, greater resilience, and specific characteristics tailored for industrial use. Meanwhile, digital tools like drones, satellite imaging, IoT sensors, and artificial intelligence are helping farmers optimize decision making, monitor crop health, and align production with market demand. At the processing level, advanced enzymes and engineered microbes are unlocking entirely new product streams from biomass. Algae are being developed for fuel, pharmaceuticals, and chemicals. Miscanthus and switchgrass are explored as carbon negative materials for construction. Plant based bioplastics are replacing petroleum based packaging, and hemp derived cannabinoids are making their way into the pharmaceutical and wellness sectors. What these innovations demonstrate is that industrial crops are at the heart of the global push towards sustainability. They are not only providing raw materials but also reshaping how industries think about resources, waste, and energy. The future of industrial crops lies in their ability to integrate bioeconomy principles, cutting edge technology, and sustainable practices. They represent a critical pathway to a world that is less dependent on fossil resources and more aligned with ecological balance and human health. The development of the bioeconomy and the rise of technological innovations are transforming modern agriculture. The circular bioeconomy shifts production from traditional linear systems to closed loop models where every component of industrial crops is fully valorized. In this context, many industrial crops operate as integrated biorefineries. For example, canola and sunflower generate food grade oils, biofuels, protein rich feed, and biomass for energy. Hemp provides high quality fibers, bioplastics, construction materials, and even medical compounds. These systems rely on fundamental principles such as resource cascading, which ensures materials are used at their highest value, sectoral symbiosis, enabling collaboration across industries, and the integration of biological and technological processes, which enhances profitability while reducing waste and emissions. Cutting edge biotechnology tools, including CRISPR gene editing and marker assisted selection, are accelerating improvements in crop traits, enhancing yield, resilience, and suitability for specific industrial applications. Together, these innovations support a more sustainable, efficient, and competitive agricultural future. The rapid development of the bioeconomy, supported by cutting edge technological innovations, is reshaping the way industrial crops are produced, processed, and transformed into high value products. Digital agriculture now plays a central role. Tools such as drones, satellite imaging, IoT sensors, machine learning, and artificial intelligence help optimize field management, reduce input use, monitor crop health, and align biomass production with market demand. These technologies increase efficiency, reduce environmental footprints, and support real time decision making. At the processing stage, innovations such as advanced enzymes, engineered microbes, and precision fermentation are unlocking new product streams from agricultural biomass. These technologies allow the conversion of plant materials into bio based chemicals, pharmaceuticals, fibers, and fuels with greater efficiency and lower emissions. New applications continue to expand the bioeconomy landscape. Algae are being developed as sources of biofuels, pharmaceutical ingredients, and specialty chemicals. Perennial grasses such as miscanthus and switchgrass offer carbon negative feedstocks for biocomposites, energy production, and biodegradable materials. Plant based bioplastics are increasingly used as sustainable packaging alternatives, reducing reliance on petrochemical plastics. In addition, hemp derived cannabinoids and bioactive compounds are generating significant interest in the medical, nutraceutical, and wellness industries. Looking ahead, progress in the bioeconomy will rely on integrated research across agronomy, biotechnology, engineering, and environmental sciences. Innovations such as CRISPR gene editing, synthetic biology, high throughput phenotyping, and automated processing technologies will further enhance crop performance, resilience, and suitability for circular value chains. Strengthening market frameworks, investment in biorefinery infrastructure, and supportive policy environments will be essential to fully realize the potential of a sustainable, circular, bio based industrial system. Ladies and gentlemen, industrial crops do not develop in isolation. They are strongly shaped by public policy frameworks and regulatory environments. In recent years, governments and international institutions have increasingly recognized the strategic value of these crops in addressing climate change, energy diversification, and rural development. A clear example comes from the European Union's Green Deal and the Farm to Fork strategy. These initiatives provide incentives for renewable energy crops, promote low emission materials, and support the transition towards sustainable farming practices. Through carbon pricing and renewable fuel mandates, policymakers are creating stronger markets for bioenergy crops such as rapeseed, miscanthus, and willow. Intellectual property and biotechnology regulations also play a critical role. The use of tools such as CRISPR and gene editing is accelerating the development of improved varieties, but governments must strike a balance between innovation, safety, and farmers' rights. Evolving policies aim to ensure that these technologies benefit both industry and local communities, rather than concentrating power in the hands of a few multinational companies. Furthermore, global trade policies and certification systems increasingly influence the competitiveness of industrial crops. Sustainability standards, such as the Roundtable on Sustainable Biomaterials (RSB) or the EU Renewable Energy Directive (RED II), establish criteria for greenhouse gas savings, biodiversity protection, and traceability. These frameworks not only open access to premium international markets, but also encourage producers to adopt environmentally responsible practices. At the same time, tariff structures and trade agreements can either facilitate or hinder the global exchange of biomass, fibers, and plant based materials. Finally, rural development programs and financial incentives play a decisive role in shaping production systems. Subsidies for precision agriculture, carbon farming, and regenerative practices encourage farmers to adopt new technologies that enhance soil health and reduce emissions. Investments in biorefinery infrastructure, research networks, and farmer cooperatives strengthen regional value chains and enable the integration of industrial crops into diversified, resilient rural economies. By aligning policy support with technological innovation, governments can accelerate the transition toward a circular, bio based industrial future that benefits both producers and society. Another major area is sustainability standards and certification systems. As consumers and markets increasingly demand proof of environmental responsibility, certification schemes for bio based products are becoming essential. Verified low impact crops gain easier access to international trade, while uncertified products may be excluded from premium markets. This emphasis on traceability and eco certification strengthens consumer trust and provides new opportunities for producers who adopt sustainable practices. Trade policies are also shifting. Many countries now prioritize domestic and strategic bio based materials, encouraging local sourcing through public procurement rules. This not only reduces dependence on imports but also stimulates local economies by creating new demand for homegrown industrial crops. Equally important is the role of technology transfer and extension services. Scientific breakthroughs achieved in laboratories must be translated into practical tools and techniques for farmers. Governments and universities are working together to ensure that innovations, from improved seed varieties to advanced processing methods, are made available, affordable, and understandable for producers on the ground. In summary, public policy is increasingly aligning with the goals of sustainability and innovation. For industrial crops, this means greater opportunities for growth, but also stricter requirements for compliance, certification, and accountability. Farmers, researchers, and policymakers must work hand in hand to ensure that industrial crops realize their potential as drivers of both economic and environmental progress. Sustainability is becoming a vital direction for the future, and global development plays a central role in achieving it. In many parts of the world, industrial crops create important economic opportunities for developing nations, enabling technology transfer and the growth of value chains that can support long term progress. As climate change intensifies, climate resilience becomes increasingly important. Drought tolerant crops can help vulnerable regions adapt, strengthening agricultural stability and reducing environmental risks. International cooperation is also essential. Knowledge sharing and coordinated policy efforts can help overcome market and regulatory barriers, accelerating the adoption of sustainable solutions. However, the future brings challenges as well. Balancing land use, developing stable markets, and building climate resilient systems require careful planning and collaboration. Ultimately, sustainability succeeds only when there is true synergy between economic needs, environmental goals, and responsible development. In the end, progress in sustainable development depends on global collaboration and on our ability to turn innovation into meaningful action. As we bring this unit to a close, it is essential to highlight how industrial crops contribute to sustainable development on multiple levels. First, they deliver significant environmental benefits. Many of these crops are perennials, such as miscanthus and willow, which not only provide continuous yields but also restore degraded soils, prevent erosion, and enhance biodiversity. Their deep root systems stabilize the land and create habitats for a wide range of organisms, supporting ecological balance. Second, industrial crops play an important role in carbon sequestration. By storing large amounts of carbon both in their biomass and in the soil, they help offset greenhouse gas emissions. This makes them particularly valuable in the global effort to combat climate change. Third, they demonstrate strong water efficiency. Compared to traditional crops, many industrial plants require less fresh water and are able to thrive even with treated or saline water sources. This eases pressure on freshwater reserves, a growing concern in regions affected by climate stress. Moreover, practices such as intercropping and habitat creation ensure that industrial crop systems support pollinators and other beneficial species. By doing so, they strengthen both agricultural productivity and ecological health. Taken together, these benefits illustrate that industrial crops are not just about profitability, they are about building agricultural systems that are resilient, environmentally sound, and future oriented. Dear students, as we conclude Unit 2 on industrial crops, I want to thank you for your attention, your curiosity, and your commitment to learning. The topics we explored, from cultivation technologies to bioeconomy innovation and public policy, show that industrial crops are far more than simple agricultural products. They are strategic resources for energy, materials, sustainability, and rural development. I encourage you to continue studying, questioning, and expanding your knowledge. Agriculture is not only a foundation of human civilization, it is the future. In a world facing climate change, resource challenges, and the need for sustainable solutions, the next generation of agricultural specialists will play a decisive role. Keep learning, stay motivated, and remember that every new idea you explore brings us one step closer to a more sustainable and intelligent agricultural future. Thank you, and I wish you success in everything you pursue.